double integrals and triple integrals. Actually, there's no limit. You can do 4, 5, or 6. We'll be undoing partial derivatives. Just as a regular integral, we did a derivative, so we found the antiderivative. Here, we'll be undoing partial derivatives. When taking an integral, we find that the antiderivative of a function. When taking a double or a triple integral, we have a multivariable function. To take the integrals one at a time, we hold all variables other than the one of interest as constant. So we in effect taking an anti-partial derivative. The other variables are treated as constants. So we look at d whatever, dx, dy, dz, and any other variable is treated as a constant. When taking double and triple integrals, the order of taking them is often, and the emphasis now is going to be on this word often. What does that mean? Often, unimportant. It means that sometimes it isn't. If the limits of integration of one integral involve a different variable, that's not the case. So if I'm taking an integral with respect to x, and the limits of integration, one or both, involve y or z, I better take that before I take the integral with respect to y or with respect to z. And the integral should be, if necessary, written in a way that working from the innermost integral outward is always correct. So if we do the innermost, this should take care of itself. If you can take an integral, you can take a double or triple integral. Confidence is important. This is the real point of emphasis with mathematics, is getting it over to students that they can do it. Use the analogy that if you add several pairs of numbers, would you panic because there's more work to do than in adding a single pair of numbers? I think not. Well, if you can take an integral and you have built the confidence that you have mastered taking integrals, taking 2 or 3 should not cause you any kind of concern. So here's an example of a double integral. What does the integral from 1 to 3 of the integral from 1 to y plus 1 x y cubed dx dy equal? Well, we're going to look at just this inner part here. The integral from 1 to y plus 1 x y cubed dx. So that would be the integral of x is just x squared over 2 y cubed from 1 to y plus 1. So, nice simple expression. Now we're going to evaluate for y plus 1, and we're going to evaluate for 1. And do the subtraction just like we would with any other definite integral. So we now have y plus 1 squared times y cubed over 2 minus 1 in for the x, 1 half y cubed. Well, if I expand this, I get y squared plus 2y plus 1. And so the y squared times y cubed is y to the 5th. There's the 1 half from the denominator. And the 2y is 2y times y cubed, 2y to the 4th. Also multiply by that 1 half in the denominator. And I'm going to get a 1 over 2 minus 1 over 2, and they will cancel. So now I have this expression, for which I will have to take the integral from 1 to 3. So now I have a simple integral, 1 to 3 of 1/2 y to the 5th plus 2y to the 4th dy. That's, look at that as y to the n. So this is going to be 1/2 y to the 6th over 6. So the 1/2 and the 6th, that's going to give me a 12 denominator. 2 times 1/2 will cancel, and this will be y to the 5th, n plus 1 over half. And so what I'll end up with is 2,187 over 20 minus 17 over 60, or 6,527 over 60. And that will unfortunately not reduce, but we're not worried about fractions in this. At this level, we want answers. Well, that pretty much sums up how simple this is. It's not something to panic over. If you would, I would appreciate you hitting the subscribe button. And even if you, I have one channel, but several playlists, you might want to follow the calculus playlist. Thank you.